Recording's going.
All right, awesome. So we're starting the new book, Designing Data-Intensive Applications. Um, if you look, you'll see that this book is actually not brand new, right? It's a couple years old, um, and it has these really great reviews. And I'll say that my first impression from reading the beginning and then skimming ahead a little bit is is I think one of the hallmarks of a great author is when you read stuff and you're like, yeah, that makes sense. That seems kind of obvious. Yeah. Yeah, that makes sense. Yeah. And then, you're kind of going through and everything is just like, this makes sense. But of course, if you had asked me to actually try to explain this or organize it or break it into categories, I don't know that I could have. But so I can see why people really like this book, because I think he's done a really good job of just trying to break things down into different categories and then explain them really well. So looking ahead, the way the book's organized, there's three parts. So the first part is foundations. And so chapter one, he introduces the topic and then he goes into building blocks. And so you sort of look at data models and then how do you actually store things in terms of being able to find things on disks, and then even further down a layer, how do you exactly encode information when you're storing it, right? Then part two gets to distributed systems. So we'll talk about replication and other things involved when you have, multiple servers involved. And then finally, part three is if you can't just have one system doing everything, then you're going to have data that's derived, data that's being collected together. And so he talks about batch processing, streaming, and different things like that. So looks really good. So where we start, chapter one, is just an introduction where he says, hey, these days, most applications are going to be data intensive, not compute intensive. So if you have a compute intensive problem, you don't really have many of these issues of like scalability or whatever, because basically you're going to bring data together and then you're just going to crunch on it for a really long time. But so, most applications, what we're worried about now is you can have a lot of users, and then, how do you actually deal with serving them up what they want and writing, when necessary, when appropriate, the information that they're pushing up. And so one of the things he pointed out is that, we talk about data systems all the time. And so, in fact, it's to the point where it is such a successful abstraction that we don't even think of it as an abstraction. People are just so used to these various concepts. If I said to you, hey, a web server and a database backend, probably most people wouldn't even think about that. Like, at some point, someone had to invent the idea of having a two-tier system with a front end and a back end that, like, now it's just like really obvious, right? So he's going to go into and say, like, well, what are the different kinds of components and what do they have in common and what makes them different, and what are the techniques that people use in order to get their defining characteristics. And then he makes the argument that if you think about all these different things that you want out of a system, ultimately it's going to boil down to reliability, scalability, and maintainability. And so then chapter one is just going through those three things. So reliability, the simple definition he gives is things continue to work right even when various things go wrong. And then he explains different kinds of things. So for hardware faults, everyone knows that hardware is not going to last forever. You're always going to have different kinds of issues. So for single machine, we've long figured out how to build servers that have two power supplies, two network cards, all kinds of redundant thing, RAID arrays of disks, things like that. But as you get larger and larger, then you can't necessarily continue to scale that pattern. And so then there's the move to multiple machines, which is really great, when you're stateless, but things get more difficult. And so then we'll get into sort of software fault tolerance techniques later, deeper into the book. He also talks about software errors, which I thought was interesting, just basically the fact that, yes, of course, they're hard to find and they can be like hiding out, realize them. But the biggest thing is that hardware errors you would expect to be largely uncorrelated, independent. And so, if you have I think the example he gave is if you have hard disk failure on server 1, there's no reason to think that you're necessarily going to have a hard disk failure on server 2. But in the case of software errors, you have some glitch around, leap days, leap seconds, you have some glitch around a particular circumstance, and then you could have this massive failure across multiple systems. You also could have cascading faults. And so one thing breaks, and then that somehow causes an overload, and another system takes that down, and then you just get this domino effect. So, so these software errors, there's no simple, quick solution. There's no straightforward kind of equivalent of hardware redundancy. You may say 2 power supplies is probably enough. 3 in the worst case. You're not going to have a triple power supply failure in the time it takes you to swap one out. But for software errors, that could not be the case. It could be the case where all of a sudden all your operating systems glitch simultaneously. And then what are you going to do? And then he made the case for human error. So I thought that was kind of interesting, that basically you're going to have operators, you're going to have not just the people who wrote the code, but operators and whatnot. And people are always going to have to apply patches, do various things, keep things running, and so they can make mistakes. So he has a list of them. I didn't list all of them here in the notes, but obviously you can just try to design things to minimize the opportunities. And I like this idea of decoupling. So if people might make mistakes, then you just sort of have the place where they make the mistake be not tightly coupled with where the failure is, so that there's more time to recover, to realize there's a problem, or it's not as fatal, that there's sort of a second step that people don't make mistakes on, that can help prevent this. And then obviously if you have a system that is sort of self-recovering, and so it's really easy to back things out, to roll back changes, for example. Years ago, I worked at a small startup, and when we applied patches, we were just sort of manually applying these patches to our code. And if there was a problem, we had no ability to roll back. So if something really badly went wrong, then we had to kind of write a new patch on top of the old patch that would somehow either undo one thing or fix the problem. But we did not have the software engineering where we could roll things back to the previous version. So obviously that's something that's really beneficial, where if you have a mistake and you just quickly roll back, then the impact can be minimized. And he talks about also like monitoring, training, things like that. So that's the reliability. That's having the systems continue to work. That's functioning both in terms of like, the system running as well as the system working correctly. So I don't know if I'm going really fast. I'm just going to pause here, see if people have any comments or questions.
So he advised version control, right?
I don't remember if he explicitly mentioned version control, but absolutely, there was a lot of commentary about being very thoughtful in how you architect things, then very thoughtful in how you do, sort of all the requirements and the testing, and then ultimately, yes, I can't imagine not using version control, just because, right? You need both the ability to roll back as well as the ability to understand, if you need to look back, what did we change between point A and point B, right? If you really want to know why this thing happened, you need to know, narrow it down to what you actually changed.
Hey, Ted, I've got a comment about the software reliability.
Yeah.
I disagree a little bit with him, because, beginning of my career, I was in aerospace, for example, and that is one area where anyone who's flown, or if you know about the space shuttle, et cetera, one of the things that they do is they have multiple redundant computers on there, so that, the decisions are often taken on the basis of a polling, right? So 3 computers, 3 answers. If they all align, no problem. If they don't align, if one computer comes up with a different answer, you choose the 2 out of the 3 kind of thing, right? So that's the way that they overcame the software issues in that industry. So, and then, you know, I'll go a step further. I mean, you can also know that you're going to have software issues if your environment, for example, affects your overall system in a systematic way. Your software may start misbehaving, sort of thing. So I disagree a little bit with him. Overall, I agree with him, but I think there are examples that and cases he didn't think about.
That's cool. Thanks, Stephen. By the way, you reminded me of one of my favorite trivia questions from the 80s, which is, how many redundant computers does the space shuttle have? Do you know?
I believe it's
5.
3.
It's more.
Oh, really?
5.
So the space shuttle had 4 redundant computers, and because it was designed to handle a single computer failure. Okay, so it wasn't handling double failures. And so if a single computer fails, then every computation they do happens 3 times, and they want there to be a majority vote if there's one computer that disagrees on the answer. So if they say, how long should we do this burn? And one computer says 3 seconds and the other 2 computers say 4 seconds, then they're going with 4 seconds.
Mm-hmm.
So this is why I was like, I could have sworn it was 5, because in the case of 4, during normal operating conditions, you can get a 2-2 split.
Yeah, I thought it was odd as well.
Yeah.
I thought it was an odd number by definition.
You can, but I think again they were assuming that
I mean,
if
you can
like
always,
just a cosmic ray flips a bit, that you're most likely going to have
still
a 3
do
to 1 vote.
3-1. Yeah.
Yeah, the other thing that I remember, that now that you're reminding me, sorry, we're going off on a tangent, is I remember when I was back in university, we actually had to do algorithmic proofs of code, if you ever had to do that. And so one of the exercises we took was we took a small snippet of code and you know, proved it mathematically that it was working properly and the boundary conditions were correct, et cetera, et cetera. And we were told that something like on the first space shuttle launch, something like 60% of the code had actually been hand verified this way.
Wow.
There's a whole process called the clean room technique for writing code that one of my professors wrote a book on that would also be worth reading. If you just go read about zero defect software development and find his book, it would be an interesting read, I think, for a lot of you.
And can I ask, does
briefly,
that
what is the
does that require a specific programming language that has certain features, or can you do it
Nope.
with any?
It is a process of iterative implementation, starting with comments that represent the mathematical logic that you're trying to follow, and ultimately resulting in code that implements those formula. So it's basically comments and then whatever language of choice.
Cool. Thanks.
You're welcome.
Wanna,
Dr. Stavely, S-T-A-V-E-L.
If you want, you can just put something in the chat.
Yeah, we'll do
people
that.
who want to can follow those links. That's awesome. Thanks.
One of the interesting things that they mentioned in the chapter that I've looked at a bit is Netflix's systems for kind of determining reliability and testing reliability. They essentially just, I think they call it chaos monkey. They basically just turn systems off, cause errors, do everything, and they make sure that everything is resilient to the various different outages and stuff that they might come across. I just thought that was an interesting concept, that they cause intentional failure in order to make sure that it fails in the way that they want and fills in those gaps, basically.
Yeah, the joke is Netflix is a monitoring system and a operational platform that occasionally streams video. They spend more on their operational readiness platform than they do on the actual streaming service.
Oh. And then of course, some of us are dinosaurs where, we remember Netflix not for streaming.
Oh.
We used to actually, look forward to the red envelopes in the mail.
Yeah.
Cool. Well, thanks everyone. That was really helpful to have that discussion. Okay, so let's talk a little bit about scalability. So, any system, even if it's working well, if you have 10 times as many users, 10 times as many requests, whatever, things are not necessarily going to continue to work the same, right? And so I thought the author had an interesting definition. So, nothing is infinitely scalable. But he says, planning for scalability means that if the system grows in a particular way, what are the options for coping with that? And so, if a system has many more users, but they're not on very frequently, then maybe you need to do nothing. But if you have 10 times as many simultaneous users, then what? Well, what if you have the same number of users, but they start, posting tweets 10 times as often? Well, your system may not be designed to handle that. And so for different kinds of growth in different kinds of ways, then you may need to have, different things in terms of how the system is designed to be able to scale. So if we're going to talk about this, then we need to formally define some things. So first we're going to have load parameters. And so the example they give is, the number of tweets per second. So you can talk about average tweets per second, 4,600, or peak tweets per second, 12,000. I would imagine, by the way, that those numbers are a lot higher now, right? Does anybody know, like, how many tweets per second there are these days? It's got to be like way more than 4,600.
This book was written, what, like 6 years ago? So probably like, let's say, a factor of 2 or 3, 4 times that. So
Yeah.
peak of like 36, 48, maybe like peak of 50K per second.
I think I read somewhere in something that the author said it took him 4 years to write it. So it was published, like whatever, 4 years ago, I don't know, 3 years ago, but
Like
chapters could have been put together, like you're saying, 6 years ago or something.
Yeah.
I think I remember reading some article, but it was from earlier this year. I think it said there are like 6,000 tweets a second. Just someone did a little analysis of how many tweets there are per day. It's still 6,000 a second as of 2020. But that's like actual. That's not about what the load bearing is. I'm sure there are spikes where there's much more, but realistically, as of 2020, it was 6,000. And they basically just found that by taking the total tweets in the year and just breaking it down. So,
I mean, that's a lot, but that's not like crazy, insane numbers.
There's a pretty interesting statistic for how many like seconds of, or how many hours of video is uploaded to YouTube every second. I don't remember the number off the top of my head, but I'm going to look it up. I read it like a week or 2 ago.
Yeah, I bet that they're writing way, way, way more gigabytes on YouTube than on Twitter, right?
Oh, no doubt.
I looked up. Okay, I look up the Twitter statistics for my own project, and I discovered that Twitter user amount, Twitter user community didn't grow up for the last like 5 years because there was a lot of quite a number of new platforms where people prefer right now to go.
Okay, cool, thanks. So then there was this example. I didn't repeat the content in here, but I thought it was a really cool example where he talks about the different designs that they used to cope with dealing with the updating the home timelines. So when you send out one tweet, or when 4,600, 6,000 people send out a tweet, basically you need to write those down, obviously, to a database somewhere. But then you have this problem of somebody wants to look at their home timeline, and if somebody's super popular has a tweet, then you've got millions of timelines that tweet could potentially appear on. So I don't know if anybody had any questions or wants to talk about that example. I thought it was nice to actually see them talk about, hey, they went with architecture option number 1, then they switched to option number 2, and actually now option number 2 is even breaking, and so they're going to this hybrid, more complex thing that you wouldn't have picked initially going out the bat, that, hey, let's do this complex thing where we do, a blend of 2, but a little bit of 1 for special case, super celebs.
I think that's a pretty interesting problem. I was working on a site with one of my friends, and it's kind of interesting the different ways that you can break things using different parameters. So we were seeing, oh, we can't do it this way because then that's going to be too many web requests, or we can't do it this way because then it just breaks the page because there's too many friends on the page and stuff like that. It's just kind of interesting to look at it and see what the different breaking points are when you change the different parameters.
Yeah.
I was wondering if there were just the two cases still, since this was written quite a while back, for the posting the tweets and the timeline. It just gave those two options. I was wondering if there were more than that, if anyone has experience with it.
I'm embarrassed to say I'm a dinosaur. I don't really use Twitter yet, so I have no comment on what the other use cases are.
They just added fleets too, which is sort of like Twitter stories. So that's an entirely new mode, but I'd imagine there's sort of distribution of that is probably similar to just a regular tweet, because you're dealing with the same thing of one person potentially having 20 followers or 2 million followers. So you're kind of dealing with the same different order of magnitudes of distribution there.
Ryan, for this fleet thing, is it do you get the sense that people expect it to show up as quickly as tweets, or can there be more of a, like if I post something on Medium, I don't really care if it's there that second or if it shows up, 2 hours later, right?
I don't know. I feel like fleets, the only difference is they disappear after a certain amount of time. So maybe that adds some complexity in terms of they need to make it disappear on time and quit being made available. But other than that, it seems like for the most part, it's just the same as regular tweets.
Mm.
I have a little bit of question. So obviously you have all the tweets kind of timeline cached in. When people are commenting in real time, because I'm not a big Twitter user, do you guys see those comments come in real time, or do you have to click in to the tweet and then they start populating in real time, more like a messaging board? Does that question make sense?
It's kind of a static thing. So it's just like a normal web page. I haven't necessarily seen it be a live update thing. I typically still have to basically say refresh the page or click on this thing again, and then it will show me the new updates.
Because I think in Facebook, I believe they do have like the little bubble messaging when people are actually commenting. So I didn't know if that was an application in Twitter as well.
Yeah, I've seen.
Yeah, I think Twitter also shows me on my phone if there are new tweets I should be interested in.
Okay.
Yeah.
So there's occasional background refresh.
Yeah, you can enable notifications or disable, like for any app, basically.
Yeah. But there's most of the apps have a background refresh, and so they'll periodically just check the server again or get a push and send you stuff. Twitter does also have a messages section where it does have that, so-and-so is writing kind of, instant feedback kind of thing, but that you can't see if someone's writing for your tweets. You just see once they post it.
Okay, cool.
Two different systems.
So I suspect that architecturally, comments aren't really that different from tweets in the sense that you expect to be able to see them timely, okay? And these days, even like a static web page, there's async IO, right? And so, so web pages have the ability to, without you explicitly refreshing, just effectively, they can go back and ask for more data, and they can do it in fancy ways. But net, it could be as simple as the equivalent of doing a refresh and getting all the data back and seeing if anything's different, right? I'm sure they do it much smarter than that, but I'm saying the really dumb way would just be to have a shadow thing in the back, and you say, hey, refresh. Oh, look, there's another comment here. And then you can pop something up on the screen that says, you know, new comment, and let the user click on it to see it.
Awesome.
I read a little like design study on that about how they can auto update newer comments and stuff. And they essentially found out a lot of users didn't like that because it would essentially just move over what they're what they're actually reading. It would just scroll it up. And that's how it was first implemented in a lot of apps. So what they've begun doing, which is like the common design principle for it, is just have like a little bubble, like say 3 new comments available, touch it and it brings them in. So you don't really refresh the page, but it just gives some sort of indication that there's been new like comments towards whatever post you're reading. I think
Well,
there's a YouTube beta for that too. So like if you're reading comments, for some users in the beta, it pops up like 6 new users have commented, but it's not just going to auto scroll it down. So that's being implemented in a lot of apps today.
That's cool. Now that you mention it, I've noticed that. So it's not that they don't have the technology or the bandwidth to auto update. It's that actually it annoys people. And so they tell you about it and have you manually click unless you're otherwise.
I think it was I think the study was someone doing a design critique of Facebook Live videos. I think that's what it was, and how it would just automatically keep scrolling and you couldn't follow the chat properly. So they redesigned it in a way where you could do that, and then they ended up switching over to Facebook and implementing it. So.
That's cool. You know, I like reading about baseball analytics, and one of the sites I go to, Fangraphs, has ads interspersed in the article, and the ads are different sizes. And so I'll be reading the article and then the ad will either rotate or it'll populate, and then like my screen will scroll down and then it'll like scroll up, and then like it drives me nuts. I'm like just trying to read this article. Okay, so let me move on. So then the next thing he talks about, so you're describing load parameters, and then the next thing is how do those load parameters get measured in terms of the result, the performance. And so he said, typically it boils down to response time and throughput. And these days, most of the time it's response time. That's what most of these web applications, whatnot, that's what you care about the most. And so when looking at that, typically you're not going to use the average, the arithmetic mean. If you want to know the middle, you would typically use the median, and you'd use percentiles. So you would say, 95% of the response times are within X many milliseconds. 99% of the response times are within this 99.9, however many nines you want. But basically you're describing the performance in that way. So it's not really, it doesn't really help you if, say, you have 40% of your responses are in some totally microscopic time, because really what you really care about is sort of the bad experiences. So even if you had 40% of the users who could somehow magically get a response within 1 microsecond, it doesn't really help the fact that you've got 10% of your users that are off at 3 seconds, right? So that's why typically it's thought about in this way. And then he talks about scaling up and scaling out. So scaling up is fairly straightforward in the sense of, if you buy a faster server, a server with faster CPUs, with more cores, with faster disks, faster memory, more memory, whatever, you will get some level of performance improvement. But the problem is that there are limitations to how much you can scale up, and it gets expensive once you sort of leave the commodity hardware range. Once you get into more specialty, high-end hardware, then things start getting more expensive very quickly. So scaling out is really the only technique that works when you get to really big things. If you're Facebook, or like we talked about, a Netflix or Twitter, you have to scale out. So things that are stateless, very easy. You can just clone, replicate as many as you want. But really the trick is, how do you deal with stateful systems? And so that's basically what the rest of this book is going to be about, is all the different ways that people have come up with architecting things to deal with that fundamental problem. All right, any other comments or questions about scalability before we get on to just that last part to maintainability?
Actually, I do have a question. So this is referencing Twitter's like second method in terms of like dealing with fan out, where they use caching for each of the users' home timeline. So from what I've seen, they kind of like basically, I would assume like with caching that requires space, right? So it's kind of like a trade-off where you're creating caches for each of the users, and that takes up space, but that reduces response time for the users, right? So I just kind of wanted to see, like in terms of these choices, they're kind of like gauging trade-offs.
So you're talking about, unfortunately, it's split across pages. You're talking about sort of the trade-off between option 2 at the top of this page and option 1 at the bottom of this page?
Mostly just focusing on 2, where with caching, it requires some resources, right? So it's a trade-off of like having to use more space for caching, as opposed to, well, I guess it also ties into 1, where for 1, it requires like response time to actually do the query to send that back to the user. But with caching, you can do that beforehand, so the user doesn't have to wait.
Yeah, I suspect that whatever, you know, at any given moment in time, if there's, you know, 100 million people on Twitter, that probably at most, you know, 10, 15 million of them are on at any one point in time, right? So absolutely, when you do number 2, you are caching these home timelines for every single person. So you're taking up a ton of disk space, because even if some guy only logs on to Twitter once every 3 months, right? You are caching that and you're updating it over and over and over and over and over again, you know, for all the people that they follow. You know, every time someone they follow makes a change, that you're updating that. And so you could make, you know, thousands of updates, and the person would never see any of those until they log on again 3 months later.
Right.
There's an article out there, like just from the standpoint, like the Twitter's Kafka adoption story. So there are ways of basically doing this caching, but only doing it for the users that are currently online. So basically, it's an optimization on top of this to try to reduce that issue.
Right.
But what you're kind of keying in on is it really comes down to, yes, these are all design trade-offs, and you have to decide, you know, what is kind of your, you know, what are you willing to pay for? What are you willing to deal with, both the financial as well as the technical complexity to give better latency or you know, better experience.
Right, and I would imagine that we'll be seeing this more often throughout the book, where as we kind of like go through the different types of like databases and different methods, it's a matter of like gauging the trade-off between what you want versus what you have to pay to get or to use that. So it's good to see early on.
And the fact that they've implemented those trade-offs regarding the celebrity tweets versus others kind of gives an indication, I think, of you know, what exactly, where that cost balance is for the, you know, writing the timelines versus doing the SQL queries.
Yeah, I mean, it's possible that this thing at the end where we talk about the hybrid approach, that may have just been to get the performance that they want. But what Chris was talking about, where like they figured out some algorithm to say, hey, you're online, I'm going to update your home timeline, you know, in real time. But, oh, you're not on Twitter? Well, then I can sort of, you know, push that off. That's probably much more just a cost optimization that, you know, we don't need to pay for as much hardware beef to update everybody's home timeline and take up all that disk space and all that CPU. if most of those people aren't even on Twitter right now.
Might be a bit of a tangent, but there's a talk by Dan North called Decisions, where he basically eviscerates a bunch of stuff where it's like, oh, what's better? Is Agile better? Or is, are monoliths better or microservices better? And it's like, it all depends. It really depends. So it's a great thing. If you're really looking at software architecture, it's a great conceptual talk.
Well, and one of the things I really like about this book, or I should say this chapter, is he does emphasize very, very clearly that, performance is very dependent on your business, what performance means, right? It's going to be different for a Twitter versus Amazon versus, I don't know, Boeing or something like that, right? So all of these parameters that he's talking about when he talks about, scalability and reliability really just depends on your business model and your business. And I really like that he took that approach rather than here's a generic that'll solve it for everyone.
Yeah. Yeah, I would say that, if you think hard, there are probably a few patterns that that you don't really have to think about too hard anymore. So for example, the idea of whether or not to use RAID arrays for your disks or not. Now, I know there's different RAID configurations, okay? But these days, basically, everyone's going to use RAID. You don't need to think about it. That's just sort of, a solved problem, right? And there's probably some other things, just some basic things that we don't even think about anymore in terms of I don't even know. You're going to have CPU caches, level 1, level 2 caches. Obviously, there's different sizes and there's trade-offs there, whatever. But yeah, unfortunately, a lot of these things, it really, you can't just have a 30-page book that says, by the way, this is how you build scalable systems. Just do it this way, because it depends so much on your workload, your use cases.
Yeah, I think, Ted, what you're talking about, effectively what you're touching on is commoditization, right? So when something becomes so common that everyone is doing it, it usually ends up becoming commoditized, at which point then it becomes eventually something evolves around this is the de facto way we deal with it. Right. And
yeah,
so,
but also because the benefits of RAID come with very, very few costs. Right? There's a lot of pros and almost no cons.
Well, yeah, I think that's a more recent statement, perhaps. It used to be the case that disk space was very expensive, right? In which case RAID was very expensive, because we've known how to do RAID for a long time, but it's become de facto since the cost of storage has gone down, at which point, yes, your statement now holds that there aren't too many, downsides, but it also depends on what volume that we're talking about.
All right, fair enough. So perhaps it was too brave of me to try to come up with an example of something that everyone's going to agree on.
Well, here's an example of commoditization, right? One that I remember reading in business school, and that is spell checker, right? Once upon a time, for those of us who are pre-dinosaurs, you actually had to buy the spell checking and grammar checking program separately, right? It was an extra piece of software that you bought on top of your word processor to obviously to check spelling and grammar and all that sort of stuff, right? Over time, since everybody started doing it, became commoditized, became built into everything, and now you don't even think about it. But it's because everybody needs to do it. We came up with a solution for it, and it just got implemented as a de facto.
Ted, I will build off yours from the standpoint of, I'll agree that there is a RAID commodity that is behind a lot of stuff, but I think storage in general, when we think about it sometimes, especially for certain use cases, we've commoditized that in the way of there's Box, there's Google Drive, there's Microsoft storage. Take your pick of, there is a service out there that is basically a utility commodity service that is providing this, so you don't even have to think about your RAID setup and whatnot, right? So we've gotten to RAID and we've gotten past RAID because we've been able to build on top of that, right?
Yeah, but I don't know if you guys would agree, until somebody invents some new, much cheaper form of memory that when you use, my whatever Google Drive, that there's a RAID array underneath that they're not somehow using non-array disks.
Don't know.
Okay.
I mean, as a DevOps engineer, I rarely use RAID. It's just like, I mean, I do sometimes. A lot of applications I have are stateless, so it doesn't matter. But when I have to actually, manage data intensive applications, I usually use a managed service, which does all of it for me. Like, in AWS, they have RDS. I'm sure it's using RAID in the backend, but there is there's a failover instance there. So there's literally 2 RDS instances. I don't know if it uses RAID, but usually whenever I have data that I really need to hold on to, I use RDS or I use AWS S3. And S3, it has to be using some form of RAID and distributed systems because they claim it has 11 nines of durability. So for like every million files in 10,000 years, you'll lose 1 file. I'm not sure if other DevOps engineers do something else, but just in my experience, like RAID is something where I think was very common like 10 to 15 years ago. But in the cloud age, I just don't see as many people using it.
Okay. Well, that makes sense. Yeah. So if you have multiple web servers, then the operating system for those web servers doesn't necessarily need to be on RAID. It could just be on a single disk. And when it fails, then you just fail that whole web server, but you've got however.
Yeah, you have like 20 other servers. Yeah.
Okay, cool.
Doesn't that mean it's just all abstracted away for you anyway, that like you're really using it, but you just never see it?
Well, I mean, in a way, when there's a load balancer, and the load balancer, I make sure everything's highly available. So I won't necessarily make sure that, all like in AWS, wherever it's using Kubernetes or just EC2 in an auto scaling group, I make sure that if it's stateless, it can be recovered really quickly. So if somebody, half my servers go down, I still have a few of them that are up, and then it can bring up new servers. And I also try to make sure that they're in different availability zones. So if there was a natural disaster, they can still come up. I have thought about adding RAID to the individual servers, but it's honestly a lot of work and a lot of extra costs if I'm just expecting to bring it up and down within a few moments with the cloud. So it's not that RAID is bad. It's just, and when there's so many managed cloud services and we're doing all our infrastructure as code and we're already being able to tear it up and down, it's just not as useful anymore.
I think it comes down to, you got to decide where your fault domains are.
Yeah.
And 10, 15 years ago, because we were working, more directly with some of the servers, those fault domains ended up being the disks because those disks were exposed up to stuff we were seeing. You take something today like RDS uses EBS as its storage medium. That is very highly redundant on the back end from the standpoint of there's definitely some kind of RAID system. It may not be your traditional RAID, RAID 0, 1, 10, 5, take your pick. There might be something erasure coded based like S3, but the system itself does have a high redundancy behind it, such that you don't even notice if Amazon has to do operations on the underlying disk, or they even have to move that entire EBS volume to another, storage segment inside of theirs. All of that is they're doing multiple fault domains, but deciding to cut it at, say, the availability zone. So now, as we think about it normally, we're like, oh, we can't think of stuff at a disk layer. We have to think of it at the availability zone or the region or some other fault domain that makes sense to us. So again, it's kind of that moving up the not the stack, but moving up the commodity items.
I mean, EBS volumes do fail. I have set up RAID before.
They can.
Yeah, it does happen. It's just,
yep.
I mean, it's just knowing where you're going to design fault tolerance. I mean, if I was doing an on-premise data center and I was managing that, I would absolutely be using RAID. There'd be a lot of stuff I'd be doing for redundancy. But with stateless applications, as long as you can like bring it back up using code, I don't think it's as important. When it comes to distributed systems, like you're using something like HDFS or something like Hadoop, there's, you know, then maybe there's a need, but it should already be replicated in systems like that. So you can survive like 2 or 3 nodes going down and not be interrupted.
Cool. Thanks everyone.
I got one quick little thing. Just hardware makes up for a lot of problems for software, because we were building software for IBM 370 mainframes back when 600 or a megabyte of RAM was, or a lot, and disks were a 10 megabyte disk would run you a lot of money. And what we found at EDS was that the hardware, you know, the software engineers made up a lot of their issues with it. And then as things have changed, 2 areas that he has covered in here, you know, it's like caching. It's really memory caching. So you're sitting in solid state RAM, not on disk with this stuff. And the cache doesn't change, which is interesting. When you put stuff in cache, then you have to physically manage that. So you throw this stuff in cache, then you have to dump it out of cache. And if something changes from a time when it was put in memory to where you want to display it, you have to re-update that. So you have issues with that. But then an area that they didn't cover was threading, that I'm not sure how much people get into threading now, because the hardware is making up for a lot of sloppy software writing. But it used to be you'd actually be looking at threads, CPU threads, and programming what was going on with simultaneous parallel processes. And that's an area that's really pretty interesting for scalability. I know Visual Studio and C# and that they still do, you know, threading. That's just kind of a thought had.
Yeah, I don't think in this book, I don't think there's any discussion at the level of threading, although I think you could probably take some of the things that we discuss in terms of, you know, separate workers trying to share data, and how do you deal with that? Because you need things to be thread safe, and then at the same time, you know, you I don't know, I'm not going to say it well, but so I think some of the conversations around what in the book might be a discussion of separate servers trying to talk to a common database in the same way that would apply to separate threads, all trying to hit, you know, common memory or other storage.
Yeah, the book's a little behind time because it's the cloudless server farms now are the big thing. So, you know, it's like what we do is we just add servers. So we've got 2 servers, and if we want to, we just add 2, 4, 5, 10 servers. And, you know, as long as you manage because it's a stateless environment, that, you know, one server knows it's requesting something that somebody did before. You just scale it out with hardware. It's actually very powerful and really inexpensive.
Well, Stephen, I'll be interested to see if at the end of the book you still stand by that statement, because he is talking about data-intensive applications. So a stateless app does not qualify as that, as a data-intensive application, okay? So for data-intensive applications, I think that it'll be interesting to see whether these principles really hold, and that whether it's cloud or on-prem doesn't really change anything in terms of, you know, replication, sharding, you know, these issues of consistency, right? They're still the same fundamental issues that we're dealing with. Obviously, some of them you just buy commodity. You know, you say I'm buying from this vendor, but that doesn't mean that vendor hasn't fundamentally had to deal with these same issues over again.
Yeah, I agree, because we have an N tier with a backend, a SQL Server backend database with a stateless, you know, up front doing a lot of computations.
Right.
I'll look forward to finishing the book.
Yeah, so I don't think you'll ever get there, but if you ever got to Twitter size, that number of users, you would not be able to have a single backend. And then you would have to choose from the various, you know, things talked about in the book. Okay, so I'm actually gonna just finish up here with the maintainability section. I thought it was interesting, like if you had asked me to pick 3 things to define, you know, data systems, I would not necessarily have come up with that quickly, but I think it makes a lot of sense. And so he talks about 3 elements of it. I'm not going to go into too much detail on them, but operability. So obviously, if it's well designed so that people don't make mistakes, that it's easy to use, you can have self-healing processes. That's a benefit. And then simplicity, I think. So even that example we talked about Twitter with the new third option, the hybrid option, whether or not that saves them some money or whatnot, clearly they are paying in terms of complexity, right? They've got this one thing that's doing, all these rights to people's timelines, but then they have another place where they have to designate who's a celebrity. And then when you go and say, I want my timeline, it says, well, here's the main part of your timeline, but I have to merge in any recent tweets from celebrities that you follow. So clearly, like even on that simple of a scale, they've added quite a bit of complexity if to do that sort of hybrid thing. So he comes up with the definition of accidental complexity. So complexity that's not inherent to the problem. It's just you've implemented. I would say that when I complain about IT at my company, I didn't have this definition, but probably I complain about accidental complexity all the time. Then the second thing I complain about is evolvability, the last topic, which is you didn't plan for the fact that, we might want a different script here. Like you should have seen it coming. It should have been designed in a way where we could have, new different scripts or, a script per state, a script per customer, a script per whatever. And then I liked the conversation about how abstraction is a fundamental concept that simplifies things. Right. So whether we're talking about commodity software, commodity hardware, right? If you basically, you guys were talking about like Amazon RDS or whatever, right? You're like, I don't need to know if it's RAID or how they do it or whatever. They give me this interface, this guarantee, whatever you said, Keegan, 1 million files, I'll lose one every 10,000 years. Like that's a great abstraction because I just read and write from that storage and I don't need to know all the pain they went through to figure it out. And I forget what the example was in the book, but right, he talked about how like several layers of abstraction built on top of each other. So if you have a really good one. So I think that's going to be a theme. I haven't read the whole book. I think that's going to be a theme we're going to see where basically if you have a certain kind of data store, if you have a certain kind of replication system, then it ultimately can abstract something out for you and say, now you don't need to worry about those details. We've taken care of them for you.
You also give up control though. Like I'm just going to bring up AWS again. So during Black Friday, that week of Black Friday on Wednesday in Virginia, AWS's Kinesis service went down, which is their streaming service similar to Kafka. And when it went down, it brought down CloudWatch, and all of the other services what were dependent upon it. So not half of the internet, but probably about like 5 to 10% of the internet was like a bunch of websites to stop working, a bunch of web services to stop working because US Virginia is one of the biggest regions. So having these managed services, assuming they set their SLAs and they're correct, but you can't always depend on SLAs. So sometimes if you can do it yourself, and you're a big enough organization, there are advantages. It's just I'm going to usually trust Amazon over my company to make a managed service, but just know that these just because if you use a SaaS platform or a cloud service, their uptimes they're not always up. And from what I was reading online was SLA agreements. It's very hard to actually go after a cloud provider if they violate the SLA for compensation. So like let's say S3 has this, they say 1 in a million files will be lost. You lose like 5% of your files or something, or it goes offline. You can try to sue Amazon, but you have to still show how much money you lost. You have to hire lawyers, and it's a very much an uphill battle. So using these managed services, like they're really good services, but I wouldn't depend on SLAs 100% because they can, you know, people are human. Things go offline.
Yeah, thanks.
I think that definitely is a big trade-off when you're using those managed services because it's kind of abstracted away from you. So we were talking about RAID. They might be using some alternate format of RAID. So you might say, okay, we don't actually value reliability that much. We need more speed in this case, and you don't really have an option. And so you don't have control over those decisions potentially. Maybe you don't need all of those extra the extra reliability factors.
Yep. Yeah. So those types of trade-offs, you don't get to pick your right performance or whatever. One of the things I like to complain about is I'll be looking at baseball scores, and somebody will have just scored, and so it'll be 1-0, and then I'll refresh the screen and it'll say 0-0 again. It's like, what? It just went backwards. Okay, so then the last bullet I have on here, I already mentioned evolvability. I'm not sure I completely got his analogy. So he talked about agile development, and I understand agile working patterns. And then he sort of said evolvability is agility at a large data system level. And I mean, on the surface, that makes sense, but I don't know if I really deeply grokked that. So I don't know if anybody has any comments, if they either also didn't quite get it, or if they can maybe help explain like how evolvability is a lot like sort of agile development.
Well, I mean, I would say one thing is like the use cases that your data is solving, right? If you obviously a lot of statistics are made up, but there's if you look at any organization, the percentage of data that's not even being used, right, or is being analyzed or anything like that is really high compared to the amount of data that is being analyzed. And so you don't know what problems you are going to have to solve in the future from a data application, right? And so being able to take in new data sources, surface up new data sources, allow different types of technologies, things like that. I mean, to me, there's a new data product, seems like every day being announced, or a new update to cloud providers, things like that. So the data platforms are constantly evolving, and if you built kind of like, and I'm going to use the term BI systems, right, in the past, right, in the old kind of nature, the biggest complaint was if you wanted to add a new field or something like that, it would take 6 months to get it through the system, and right, and that's just not the speed that data intensive applications need to function at in this environment.
Mm-hmm. Thanks, Andrew. All right, that's all I had. I don't know if anybody else had any comments or questions or any place they wanted to kind of go with this conversation.
One of the things that I was thinking about, they used the Twitter example earlier, but when I was reading through the book, I was kind of thinking about how incredible it is YouTube is able to feed out such a large quantity of content instantly, because you think about one of the things that Andrew was mentioning is they probably have billions of gigabytes of video that is basically never going to be viewed, but it still needs to be available almost instantly. And so it's kind of that skewed problem like they have on Twitter, where there's some content that is basically never viewed, and then there's Baby Shark that's going to be viewed 7.3 billion times, and they need that on enough servers to be able to be fed to everyone. I think it's just kind of an interesting, I'd be interested to see how you even solve that problem, because you need so many copies of the data on so many different servers, and you need to make sure that it's the right stuff that's available, because everyone just expects the page to load in 2 seconds, basically, and the video to be immediately available. You can't wait for another server to be available to feed the video when someone else is done watching. I just think it's an interesting problem.
As far as timing, I guess it does help that they have so many commercials for the people who aren't on YouTube TV or whatever. Just the idea just gives them a little bit more time to buffer for some of those users. But yeah, definitely interesting. I was also thinking about the because obviously we were just more talking about time and how time was recached in, but YouTube does also like such a good job with the whole ranking process. And like if you've seen the video before, if you really like this specific YouTuber, then it'll update accordingly for the cache. I think it's just really interesting how much stuff that they can do for the ranking system.
Yeah, so if you've ever, I know there's probably articles or presentations about, how Netflix, for example, handles like the rollouts of new series, and it's pretty interesting. It's not really as much a data problem as it is a CDN problem. Basically, like how many data centers is that video, copied to, right? Because typically you're just setting up a stream, and it's going to be streaming from some type of video streaming service, and it's really about for those things that they know this is going to go live at whatever 8 p.m. on this day, and everybody's waiting because it's super popular. They have different capabilities around that than they would for a YouTube, where it's like a video that I upload, which maybe 2 people will watch, right? Maybe my mom and my dad, so it's a little bit different problem. I mean, the person before brought up recommendations as well. That's another thing, and I know it's something that when I worked at the Pluralsight that we worked on was, typically there's usually a offline piece of it and there's an online piece of it that part of it is going to be based off of what action you just took and kind of an algorithm that's been put forward. But then there's also usually back-end processes that highlight new videos or new algorithms or things like that. So it's a fun, interesting problem to solve.
So you worked at Pluralsight. Were you working on something similar to, not necessarily similar to YouTube, but you had similar problems?
Yeah, so I mean, I was on I'm no longer there, but I was on the data team there. So we were responsible for handling all the data that's built through the system, built through the UI, feeding data into recommendations, things like that. So yeah, I mean, there was most of the videos, for example, were not served from, let's say, Pluralsight server, right? We use, just like most other companies that serve up video, we're going to use a content delivery network, right? From one of the services. Can't think of all the names of them now, but Amazon has one, Azure has one, Google probably has one. There's third-party services that have them as well. That's all they do is deliver content around the world, right? And that's what they specialize in. So I think Cloudflare is the one that's popping into my head as one, but that's what they do. And so we were responsible for getting the video, getting the user the link to view the video, but as far as serving up the content, that we left that to CDNs, because it's like, what do you want to be an expert in, right? And we didn't want to write our own CDN, right? It's a solved problem, right? And that's what, to me, what happens in a lot of the kind of data products as well. It's like, yes, you could write your own alternative to Kafka, for example, but do you really want to be an expert in that technology, or is it, if you just want to use an existing product? And that's usually the trade-off, right?
So Pluralsight is like online classes, right? Did you guys do anything in terms of like those are kind of sequential. You kind of know the next videos that people are going to watch. Did you guys do anything to help with that, or was that kind of all abstracted by the CDN?
Well, I mean, you know what, it was broken up into smaller pieces, right? So that's the other thing. It's not, if the course was 8 hours long, it's not an 8-hour video. It's, it's going to be, sections of it, right? And they're each are separate videos. And so, you're going to have the CDN is going to be responsible for delivering you what the next, thing is in the table of contents. But in terms of kind of giving them access to the video and things like that, that was all through kind of the Pluralsight platform. And obviously there's, as far, when you talk about if they're done with that course, right, in terms of recommending what course they might want to watch next, that was all within Pluralsight, right? That was all, there's an algorithm that figured out these courses are like each other. These are people similar to you of what courses they've watched. There's more to it than that too, but it's, pretty much people who bought this also bought this, right? You can kind of think of it in a pretty easy way, but yeah.
Cool, interesting.
Hey, Andrew, I'm curious, do you know what the pricing model was for the CDN? Like for a Cloudflare or a Kami or whatever. I'm just wondering if it's flat rate just in terms of like, hey, this is the number of bytes, we delivered for you, or if maybe they somehow incented you to help them know which would be the popular ones, which would be the unpopular ones, so that they could, kind of manage their hierarchy.
Yeah, I don't know. I mean, I'm sure there's probably certain levels of product right, that they have available to you. I think for the most part, it's not like when Pluralsight released a course, there was, millions upon millions of developers just waiting for that course. So, so we wouldn't have had a need of like, when the, latest Game of Thrones, season gets published, right? So there's definitely, different challenges there. So my guess is I think we had it at least duplicated into like multiple regions. So if you had somebody that was in, Australia watching a video, they're going to be hitting CDN in Australia or New Zealand or someplace close to them. So that's probably it's more about that as opposed to the kind of level of service, I would say. But yeah, I'm sure it's, how many data centers do you want to have it in? How, what kind of, performance do you need? Things like that. But yeah, I don't know. I don't have all the details there, but that's what I suspect.
Cool. Thanks. Anybody else have any comments, questions? All right, so Ryan, I'm gonna toss to you in a second to see if we want to maybe do another breakout or something else here for people who have the time, can stay a little bit longer. But I did want to first just sort of talk about the upcoming schedule. So, so we have the neuroscience talk that's on Tuesday, kind of early evening here on the West Coast, kind of later evening on the East Coast. And we have the FinTech talk that's next Saturday. It's 4 p.m. Pacific, 7 p.m. East Coast time. And so we're going to try and be really good about, we won't need to do the introductions and all that next week. So for the book club, we're going to greet people for the first 15 minutes and try and really keep it to an hour. So have people, out by 1:15 here Pacific. And then if people want to come back at 4 p.m., they can come back for the FinTech talk. So for next week's book club, chapter 2, it's going to be that same start time, but just I don't know, maybe try and be here by 12:15 because we're going to really try and keep to the timeline next week.
Sounds good. I'm thinking if we want, we can do one more session of breakout groups and then take a break before the next session.
Yeah, that sounds good. So I know some people probably, have plans they need to go, but we'll give people a second, and then just depending on how many people we have, I will try and pick a good number of breakout rooms. So
Quick
it's not too
question.
many, not too few. Yeah.
How many chapters for next week were we gonna cover?
So just one more chapter. So just chapter 2, which is about data models and query languages. And so that's going to really talk about sort of the high level, how you organize and refer to data. And then after that, we'll do chapter 3 will be how the databases actually go about being able to find things. So things like B trees and that sort of stuff. So it's about 25-ish pages. So hopefully it's not too intense for anybody for next week.
Yeah, and I see that you've already posted the meetup for next week, Ted. So if anyone needs to remember the details, those are all posted as well.
Yes, I didn't send out the announcement, but I did create it. So if anyone wants to sign up, they can sign up for next week now.
And I just linked it in the chat for anyone who wants to.
Great, thanks everyone.
All right. All right, so I think what I'm going to do is let's just try. I think a number of people are dropping, a number of people have to go. So, so why don't we just do 3 rooms, and here we go. So the rooms are open now. If you need to go, have a great week. Hope to see you at a future event. Otherwise, you can go and mingle.
Hello.
Hi everyone. Leo, you were the one who mentioned Among Us, right?
Yes.
Have you been playing that recently?
I'm one of those people who don't play games but watch other people play.
Yeah.
So
Yeah. You watch on Twitch?
Yeah.
Nice.
So,
Yeah.
I found that interesting.
What'd you say?
I found the whole addition with the audio interesting to the gameplay.
Yeah. I've been, since all of the COVID stuff hit, I've gotten much more into Twitch. I've been watching a lot more.
You have like particular streamers you watch? Or do you just stream?
I watch kind of everyone. Most of the big people I've watched at least a little bit.
I wrote down Among Us because I hadn't heard of it yet, but I still haven't quite. I'm heading there now. I hadn't seen what it. I don't know what it is.
It's a video game where you have sort of partial information. I don't know if you've ever maybe played the game Werewolf or Secret Hitler. Basically,
would it be more akin to like Clue?
Yeah. Okay.
Yeah.
I know like that.
But basically, the premise is you're on a ship. It's a simple game that you can play on your phone, actually. But you're on like a spaceship and you're going around. You're trying to do tasks, and the crewmates win by completing all of their tasks. And then there's some imposters who try to go around and kill everyone. And so the crewmates are trying to either complete their tasks or figure out who the imposters are and vote them out. But everyone's kind of separated, so you don't know who did what. So if something bad happens, you have to try and deduce with missing information who is the bad guy, basically. And it's been incredibly popular recently.
I had to
it's an old game, right? I feel like a few years back.
Yeah.
Yeah, I had to figure out what it was because my my kids we had their cousins over Thanksgiving, and all of a sudden they kept asking me, so can we get Among Us? And I'm like, what is Among Us? Like, what is this you're asking me to download? You know, so yeah, they enjoyed playing it. They actually made up their own, because there's 6 of them, so they made their own like game they played like in person, like just the 6 of them. So
yeah. I just played it last night. That's been a staple recently. Gotten much better at lying. It's a good skill to have.
Oh yes, definitely.
I'm out then. There's no way I could do that.
Yeah, it's really funny playing with some of my friends. They're too innocent. They can't lie. So if you ever catch them doing something, they won't even try and blame it on you or anything. They're just like, you got me.
I can tell that I can see some familiar faces. I know definitely Andrew from another meetup. I think I saw you, Ryan, over at the data engineers meetup as well. Do you attend those meetings occasionally?
I've been to random other ones off and on. I haven't been to any ever since COVID hit. I haven't been venturing out as much. I've been doing other stuff, but I used to go to quite a bit of different meetups.
And actually, it was thanks to Andrew. Thanks Andrew for posting the link for this. Book club, how I kind of got into this meetup. It's interesting. I can definitely tell that there's well, obviously like veterans or actual like developers within the space that actually use these tools and like actually use these concepts in real life. So it's interesting to kind of like hear their like experience in terms of these concepts. And just kind of like put it out there as like a young person, it's kind of daunting to kind of like enter the space and ask questions. But I do appreciate everyone's input though.
Yeah, that's the whole point of it. I only started doing this a few years ago, like maybe 2 or 3. And I liked going to someone else's meetup and going there and being able to talk to people and just understand stuff, because I was trying to learn all of this stuff, and sometimes just going straight out of books and stuff, it was kind of hard to tell what was useful and if I was even in the right track.
Mm-hmm. And for me, I think one of the main reasons why I asked the question I did earlier about the trade-off between caching and then response time is to kind of understand the concept of like thinking of the trade-offs that you'll have to like make in terms of making decisions. And it was clear in the example, the Twitter example, and I kind of want to do that more with the tools that are available for like storage and other operations, and just having like starting the conversation or at least bringing up some doubts in my mind within the space definitely helps solidify some of the concepts, and especially hearing experience from people who have made those decisions. It's definitely insightful.
I haven't necessarily worked with these systems all that much. Since I primarily do machine learning stuff, the extent of my data usage has typically been something that can fit on a single hard drive or SSD or something like that. So a lot of this is actually, it's not that I don't know anything about it, it's just that I haven't like studied them in depth or actually applied them. Like the whole thing of a content delivery network, I haven't looked at those in detail. I don't know what's going on with those necessarily.
And this may be a question for Andrew, because like with the whole concept of data intensive applications, like you have to have a use case, or you have to have the right situation to kind of like work with these tools. to handle large amount of data. In terms of like kind of working on personal projects, what's your experience like with kind of like fiddling around with stuff? I would imagine like within your job, you can probably test it on some of the data that you're receiving. But in terms of like personal projects, what's your experience like?
Yeah, I mean that's it's certainly a challenge, right? You know, it's kind of one of those things like how do you, you know, like trying to figure out like, well, what are the trade-offs that Twitter is trying to make? It's like, well, you know, to simulate that type of environment would cost you a lot of money, right? To even simulate a problem like that. So, I mean, that's one area where I don't know if I, you know, really have a good answer for that, because like you just, it's one of those things like you just don't know until you do it.
Yeah, you learn on the job.
You know, because a lot of times you might, you know, let's say you're using, I don't know, Postgres, for example, right? And you're like, yeah, it works fine. And, you know, but until you, you know, exercise it the most, right? Or exercise it or push it to its limits, you don't find out where the cracks are, right? You know, it's just kind of like if you think about like water pressure, for example, like if you know,